Good morning, good evening. This is my second time making the video. First time sound cutout. So this is my box turtle serial request video. Um, Hopefully it meets all the requirements. There's my name. There's the date. There's some dog food, some kit art, box turtle, printer, little pressed air, some tweezers because you always need tweezers. So this is my 350 test rig. This was the first run. It failed. For lots of reasons. One is I didn't have the software properly set up. I'll talk about that. The hiccups I ran into. So that over there is a 250 from LDO Trident. A note about size. In my experience playing around with my stealth changer, the best size for a tool changer really is going to be a 250 size. That's because there's no way the amount of time it's going to take to print like a full plate of 350 is going to be way too long. You're prone to something happening, some error that messes up the whole print. You're much better off doing smaller prints on like a 250. If you need the size, because what you're doing is like a helmet or something, I could see it, but for my personal everyday uses, a 350 is way too much. I got a 350 stealth changer, and I need the 350 for the nozzles, the 6 nozzles or the 6 tool heads, but I don't need the build plate volume. So anyway, that's my little rant, little Grant rant. A couple things about this is nothing special. I've got the Mandela Roseworks kinematic mount with these things. I like them. They work pretty good. Only negative is you can't hang stuff off the middle, so there's no. This thing only prints PLA, but that's they work really well. I got the Vitali AB motor mounts on it with the double shear support, the Vitali double shear support on the back, and that's because I want to play with the tension, getting the tension up as high as possible without breaking the belts. I want to play around with motor currents. And the metal CNC Vitali AB motor mounts just act as natural heat sinks to suck up all that stuff. I've got the Vitali's CNC front, front idlers. Um, they're just like Rama or BFI. They don't really add to the extra tension, but they kind of look cool. So this is my printer that we did it on. That's the box turtle. Keynote, first issue I ran into. I have the LDO kit, the batch 1 LDO kit. As we know, the 30-tooth gear is not, it's too big for the motor mount or for the rod. So I tried the super glue on it, and it worked. It held the gear, but I used the gel super glue, and the residue left over prevented my bearing, the bearing I think on this side, from contacting, because I need to be right up against that 30-tooth gear, and it prevented from doing that. On top of that, the gear, I put glue on both sides of the gear, and the sleeve, some of the sleeves weren't touching the gear either, because you get that sleeve that goes over the shaft, such that the end result was my wheels were too far out and they were rubbing against the lane's sides. So Thunderkeys came to my rescue, because I would have reprinted, and I did reprint the 30-tooth gears in plastic, but I have come to realize that my V2 ABS printer needs to be tuned. It does not dimensionally. It's not dimensionally accurate. Good enough for printer parts, not good enough for box turtle parts. But he came to my rescue and provided me with the proper gears and axles, and it went together a lot better. So that was one of the issues I ran into, and I'm sure some of us others will run into the same issues. I lost the picture. I had another picture for you. Let me see if I can find it. Where did I put it? I got a picture of the underside of my box turtle. There we go. So this is how I decided to wire it. Um, what I did was I put these in bundles. So every extruder has its own bundle of wires. And I originally, because I've taken this thing apart a couple times, fixing it and playing with it, I originally had them per the directions, all the wires kind of be joined up into one big bundle at the end and going this way. Well, when I went this way, it was just way too many wires because you're going to go through all these motor heat sinks and the wires are actually over here, right? The connections. So what I did was I bundled up each of the extruder's wires individually, and I brought in this little sensor right here, this little switch into that bundle. And then when I put the extruders back in, I just went underneath all the extruders PTFEs tubes and put them in, and they've held it. I don't have, and none of these wires currently in this setup right now that's working are connected to the lanes at all. They're just bundled themselves. And the respoolers have a single wire that does the same thing. I don't even bundle that up. It goes here. And then the LED wires, because of the way LDO has provided them in the connections, they don't hit anything. They don't fall on the table or anything. You can't even see them here. So they just connect together. But this is what I've done. I hear that the desiccant trays that these kind of bundle here may interfere with this desiccant tray. I don't have it, so I don't know. That's what they're telling me. So this may not work if you have the desiccant tray, but in my opinion, from a serviceability point of view, this makes a lot more sense to kind of individually bundle each extruder's wires so you're not taking everything apart. I also originally had these going straight per the manual. After watching Steve builds, I thought that was pretty smart. Let's just angle them. So I decided to copy him and angle them. So those are those. Let's see, what other videos do I got? What other pictures? Because we're all about pictures here. Okay, so one of the issues I ran into was, what the hell numbers do I use? Let me pull this up. So in here, it's config. No, it's not config. Is it config? No, it's not config. I think it's hardware. Okay, so you have this STN tool STN and tool STN unload. So Thunderkeys has been helping out. This needs to be updated, but this is his Voron Philometrics chart giving you these numbers. So 78 is here. This is a tool STN, right? So that's from the sensor to the heat break on the top of the nozzle. But this tool STN, what I was finding was I used 84, as you can see. Oh, my mouse is too small, but I'm not redoing this. Sorry, guys. Small mouse. I used 84, but it was too much. And what was happening was, let me get that picture back up, that it was respooling too much, such that over about 25%, when I was about 25% done, it would actually push out the filament further than the extruder gear. So when it went to load this, it was always giving me these errors. It can't load lane 2, can't load lane 3. It was always the middle two. And so we changed this to 62, and it worked. That just numbered to 62. So I'm sure Thunderkeys is going to update this to say tool STN unload equal to 62 millimeters. That was the big issue. The other thing I've been doing is playing around with, where's my macros? The poop. So you'll see it in the video. I poop a lot more, or my box turtle poops a lot more than it sets you to. So it's setting at 72 and 60. What I want is the full color to clear before I do. I also do a prime line. I know you don't have to, but I do a prime line and so I wanted to make sure all the color was clear, so that the prime line was just a nice line. And we'll show you that in the video and explain more why I'm doing it this way. So let's go to the first video. This is round 2. So we saw the picture from round 1, which was, we'll just remind everyone here. This was round 1, as you can see, no writing here. And it failed. It failed on the unload because of that setting I talked about, the STN unload setting. So here we go with round 2. It's pooping right now, and what we'll see if I... Nope, I didn't get that good picture of the poop. Let's see here. Okay, so moving all around. Stop moving around. Uh, what we'll see here, if it does it, if I get a picture of it. Okay, right there. So what you can see is I fully excreted the original color, which was a silk orangey red, and now I'm putting in some sort of glass blue in, and I wanted to make sure that every single bit of orange silk was gone, the previous color was gone, such that when I come to do this prime line here, it's a very small prime line, but it's a lot of waste, right? Poop in the prime line. But it's a very small, I wanted to make sure that the prime line was perfect, such that when it went to the model, it didn't blow anything out. Blowouts are bad if you have kids. It's bad for printers too. So what I did is I made sure I completely flushed it here, and then this prime line was basically done. And if there are any mistakes, it was going to happen on the prime line, and it does. But then its retract is all perfect. Everything's perfect to then go to the model and print. So it's kind of like my safety, my make sure nothing gets screwed up on the model. A little extra step. And then there it goes, it poops in. Let's talk about this. This is another thing that I added here on round 2. This is a poop tray made by M. Jonas Chat. It has originally had a brush on it, but I was finding that the brush was hitting the build plate, so I just cut that off in the slicer and stuck it right here, and it does an okay job catching the poop. So that's that video. Now we'll go to the round 5. So we're almost done here. We're getting close. We're on round 5. You can see, yeah. You get a good picture of that poop chute right there. So we're reeling in these are both. This is a silk. That's a silk. This orange silk, or this first silk here. I basically, for my filaments and my slicer, I just set one value. They're all the same. I need to adjust them per filament, but you can see the path it's taking because it does poop out or has a blowout. This candy was provided by West 3D from all the stuff I buy there, and also from Thunderkeys. When he came to my rescue, he gave me a lollipop. So, okay, what can we see here? All right, so right here is that little like blowout. So I think it's the combination of the heat and pressure of my silks. If I lower the silk temperature, I don't think it's going to happen. I think it's really temperature. But when it gets here, it kind of just does a big old blowout, little blop right there. And the nozzle hit it once, and it created this little tiny layer shift on the green. Because it did like way down here, right? It's like the orange or the red. This is actually the red. So it's this little T here. And then the next layer was green, and it kind of hit that just a little bit. That created this line here. We'll show you more in the other pictures. But that is, so your filaments really, if you're going to use different styles like PLA or silk or whatever, that you gotta, I should do it. I didn't do it, but different profiles for the filaments you use at different temperatures. So there it just is changed it, and we're going to see there's a big old poop chute. You can see it not fully set up yet. Got a little stringing that gets caught as a bunch of poop fell down. This is my cartographer I'm using. It does really good for this job because the nozzle doesn't hit or anything like that in the build plate. There we go. And it pooped away. And lots of poop. And so that's the video. Yeah. So we saw layer change. I hope that qualifies. Let me see what else I got here to share. So one thing is I was getting a bunch of errors and I thought it was a software problem. Let me see here. Let me picture. So if this airs out, if what I've discovered that if it most of your errors are going to happen when you're changing filaments, when you cut it and then you try and pull it back. If it doesn't pull back all the way, if it airs out, what you need to do, or what I've discovered I need to do, your mileage may vary, is get this filament out of the tube. So that's going to be using one of the commands, lane eject or lane move, probably BT lane move, and just keep walking it back till all your sensors, your hub is cleared, and then hit it with your next lane. So if you T1 gets stuck or T0 gets stuck, get that lane 1 out. So it's T0 lane 1, get that out, and then hit it with the T2, and then after that hit BT resume. If you do a BT resume and you've just cleared it, it's expecting the actual next filament out. So it's expecting the next tool head, which is the next lane, in the tool head before you hit resume. I was getting some weird issues with that. But that's my video. Oh, we gotta do the pictures. We gotta do show and tell. Okay. Some final model pictures. That's the final model. That's was printing in round 5. That's the underside. I got to work on tuning this too also. That's the layer I was talking about right there. That's the little layer shift caused by the blowout. A little bit of there, and you can kind of see it there. And then you definitely see it there. But all in all, I think, let's go back to here. I think it came out pretty good. I mean, it's going to, so after do a little compare and contrast here, the Stealth Changer, I think is going to be a quicker print than the Box Turtle. And that's because the tool changes are just so much quicker. So much. If you get a 48 volt tool changer, your tool changes are quick. Versus the Box Turtle, which is like an MMU style. Its quickness depends upon how long your Bowden tube is between the Box Turtle and the tool head. The shorter this Bowden tube you can make it, the better. Now mine's on the side. I'm kind of restricted because if you look, let's see, we have it in my videos anywhere. If you look at my videos, I'm using let's see, nope. I got some shelves that I can't stack on top. There's a top part of the shelving unit, so I can't put my Box Turtle on top. I'd have to rearrange the shelves 100%, which I'm not doing. And so I will deal with this long Bowden. I might put it on a box or give it its own little table just to get it up higher, so that way I can cut if I can get this up higher, I can kind of cut the Bowden to length. But if you cannot, so quickness is going to be your Stealth Changer. Ease of use and ease of troubleshooting and ease of just calibration wise, the Box Turtle, this MMU style, is going to be far and above. I didn't have to calibrate any of my XY offsets. It's because it's all the same tool head. So the Stealth Changer, you're trading speed for complexity, and here you're trading off the time speed, or this total time in prints for simplicity. I think they both have their place. This is definitely a cheaper route to take than a Stealth Changer, but just like the V2 versus Trident conversation, the V2 is obviously a cooler printer, right? Everyone loves seeing the gantry go up. Same with a Stealth Changer. It's just it's a cooler tool changer, right? Every now and then, boom, that whole gantry just zips up, changes the tool, goes back to printing. So they have their place. They both do. Like this I can see just being a workhorse. This is like your Trident. This is a Trident workhorse versus the Stealth Changer. You know, that's like a sports car. It's going to need more love and attention. So if I was to have more of these, I would probably pick up more Box Turtles. And you got that's kind of my viewpoint. Didn't ask for it, but there it is. So anyway, this is my box turtle cereal request. Thank you for your considerations, and I hope I get a cereal. Have a good night. Good morning.